Hey everybody, it's Ivan and Venky here from the Greenplum product management team. And today we're here to announce the Greenplum 7.5 release that our team has worked really hard on over the last few months. And today we're going to go through the recent releases of Greenplum over the last 6 to 12 months and really wrap up what's in Greenplum 7.5, how is it different than the original Greenplum 7.0, and then what have we got coming up in the near term on additional releases coming on Greenplum after 7.5 to keep the momentum going. Venky, anything you want to say to get started?
We have done great work for the past 12 months, and this is a brief summary of that.
Right, and the team is passionate and ready to do more. So we are at Broadcom, and I do want to announce that any roadmap is under consideration and could possibly change in the future, but we're going to mostly focus today on what's already been released, what's done, and we'll just give you a quick indication of what's coming in the near future that's not really too far out, although we have a big plan for longer term as well. So focusing in on the last 1 year of productivity in Greenplum, we're going to highlight the key areas that we've done in Greenplum 7.2, 7.3, 7.4, and 7.5. It's been about, that's like 4 releases, and we're going to keep going at that pace. So Venki, if you can talk us through the highlights of the key areas that we're focused on.
So Ivan and I have tried to categorize all of the features that we have done into 5 broad categories. The first one being faster query processing. So we have customers with diverse workloads, transactional, analytical, different kinds of workloads. So how do we want to make it faster and faster so that they can meet the SLA? The second group of features is all about having enterprise recovery solutions so that in case of recovery that needs to happen, how do we handle that? The third area of our focus is to have a rich library of analytical utilities and algorithms and extensions so that users with diverse analytical needs can focus and deliver their queries. The fourth one is a seamless streaming solution on modern data architectures like Kubernetes. So how do we handle streaming, loading data from streams into Greenplum? And the last one is to how do we deploy Greenplum on the private cloud so that we can have automatic HA capabilities.
And if I could sum it up in one word, my word would be speed. We are focused on speed with Greenplum, faster querying, faster recovery, faster data replication, faster analytics, streaming the data in, and fast deployments in the private cloud. So, yep, let's get going. We're going to walk through these one by one. So there is no feature that's more important to a database than querying the data, right? And this is now over 10 years. This is actually 10 years. I remember July 2015, I believe, was
Correct.
when we GA'd the Orca optimizer. So we've reached 1 month shy of the 10-year anniversary of our query optimizer in Greenplum. Massive effort required to get us to where we are, and we're still pushing ahead with Orca. This is really a secret sauce of Greenplum that never continues to get better. So Venki, can you walk through some of the recent enhancements in Orca and in query
Correct.
execution for Greenplum?
So Orca traditionally was designed for big data, but our customers have a lot of transactional queries too. So we have a couple of different dimensions that we have focused on in the query optimizer. One for transactional queries, hey, how do I pick indexes faster and quicker? How do I reduce the memory consumption during the plan generation? And how can I generate all of these plans, these billions of plans, the alternatives in a quick time with quick memory, like low memory footprint. There are many queries where are what's it directly on one particular segment. So if you have transactional queries that attack one segment, like hey, this data is on one segment, how do I do better direct dispatch so the other segments can do other work rather than focus on this query? I also have meeting up with the parity of the Postgres planner. So we have many features like multi-column subqueries, like say, for example, if you have A comma B in select star of C comma D, for example, or a row expression or anti-joins. These are like powerhouse queries that people have. So Orca is now generating better plans, and we keep improving the join order. Join order is the bread and butter of any algorithm. And the Postgres planner, the join order hasn't been worked on for several years and decades. So we keep innovating in the join order of query for Orca. And for a big data set, big queries, this is crucial for their workload to finish.
Right. And a shout out to the original creators and designers of Orca, really beyond 10 years ago for having the vision to build from scratch a modern big data optimizer that could be so robust and could handle so many workloads. And it just takes a long time to see that vision come through. And we're seeing it come through now. And the other thing I'd say is just this idea of mixed workload and the feedback we got over the years that a big, whether you call it a lake house or warehouse or data platform, that you need to be able to handle a combination of of big data queries with transactional queries with
Correct.
millisecond response times and being able to handle across all of that seamlessly. It's really, really great to see.
And Ivan, these queries have different needs, right? If you have big data queries, your plans are complex. So the way you all the alternatives that you need to pick is very big, but you want to do it super fast. And for short running queries, you want the query optimization to be instantaneous. So it's kind of like, battling two different dimensions. And we have done pretty good job in Orca to do that.
One example can you highlight the exhaustive 2 join order algorithm and how it's
Correct.
dynamic and how it works?
So exhaustive query, if you have dynamic programming, this is like bread and butter of join. I'm sorry to be nerdy here. The bread and butter join algorithms is like exhaustive search. You come up with all different pairs and then figure out is the best alternative for minimizing the total cost of join, which is like the number of intermediate tuples and states that you maintain. But exhaustive too, that was the naive, Salinger algorithms, like bread and butter algorithms. But then what we wanted to do is that, hey, that algorithm only handles inner joins. It does not handle left outer joins or right outer joins or full outer joins. So we wanted to incorporate that inside the query optimization of join order, because traditionally what optimizers do is that you will have the inner join part and then the outer join parts are all left strangling outside. So what exhaustive 2 algorithm is like pulling in that join order algorithm inside to encompass all different kinds of join. And that was pretty cool.
The last thing I highlight on this slide is now we have we're starting to get near the tipping point where Greenplum 7 is as widely used or more widely used than Greenplum 6. And we've got clear feedback from customers now that the latest Greenplum 7s are actually faster than Greenplum 6. So we have achieved on a major version the best performing Greenplum of any variant of any version in the world that can really do great. Okay, let's move on. Okay, so let's talk about index scan. So maybe just a real quick history about the history of index scan and Greenplum, and then how does it different when it comes to heap tables versus compressed tables, and where are we now?
So traditionally in the AOCO tables, right, Greenplum in 6 and early 7, we did not pick we only picked bitmap index scan, and we never picked index scan because the cost of doing index scan was not perfect, and we could make a mistake. So we had to do a lot of regression testing to figure out exactly the tipping point. How do we fix the cost model so that we can pick the index scan versus bitmap index scan? So what we did in the 7.2, 7.3 releases is to constantly build on the query costing model so that we can pick index scan on AOCO table and not just rely on bitmap index scan. And what does this benefit? So say, for example, if you have order by clause, right? If you have an order by clause, you don't have to do the sorting. You can just use the index scan itself to give that order, because index all itself has an order. What if you have a join query or a select query that has very high selectivity? Don't need to build a bitmap index, rather than use the index join, then just use the index or the index join to generate the correct results. So what we did the main focus we did in this work is to actually improve our cost model so that we can identify we already have indexes. So why don't we just use the index scan properly?
Okay, great. And that just goes back to that point about mixed workloads that some big scanning queries don't need an index, but if you need indexes, if you can benefit from indexes, or even almost in a sense implied indexes in joins and aggregates and PG vector, that indexes are fully capable in Greenplum 7.5. and they help in many workloads to make things faster. You can see here 100 times, 1,000 times faster on specific workloads.
And also use it in cases like where you never thought indexes was useful, like for order by, for
Yeah,
example.
absolutely. Okay. Now, this one is a bit personal to me because my first job at Greenplum was a performance engineer, and I used to go and run GDB randomly to debug a long running query. And every time I attached to the system, I saw it doing tuple operations, and I said, "What's that?" So help me understand, what is this improvement and what will be the benefit in Greenplum 7.5?
Correct. So any AO table, row table, AO row table is maintained as a mem tuple, right? And whenever we read that, we have to either serialize it or deserialize it for different operations. So what we want to do is that, hey, if I'm looking for one particular column, rather than me or the first 5 columns in a row for wide tables, and many of our customers have wide tables, which like thousands with like hundreds of columns in the particular this one, and they're only selecting like few columns of that. So I don't want to deserialize everything, right? I don't want to materialize everything. So I want to do some form of optimization that for the IO table. So what we have employed in Greenplum 7.5, it's coming soon, is the fact that we want to do partial or late deserialization. We want to avoid it as much as possible, or whether it's serialization or deserialization. Say, for example, if you're doing vacuum, I know this tuple is not going to be used. So why do I even bother, like, materializing it? Like, let me just clean it out. Like, all those, all of these chain money on the table, like, we can do these operations really fast, right? That's what we want to focus on. And
Okay.
that's what we have delivered. So here are some beautiful examples, right? On an average, we have 2x improvements. Like if you have a select query on an AO row table, you have few columns that you're projecting. We have seen. So for this example, we said, hey, I have 100 column white table, and I'm picking like the first 5 columns of that table, right? We got 2x improvement. What if you had a qual on those, like, the few columns rather than the whole thing? What if I had a subplan? What if I had a vacuum? How about creating index, right? If I do an insert into from an AO row table to another AO row table, I know how it, and it's distributed the same way. I can just take how the representation on the file is and then put it on the other side. I don't have to, deserialize it and serialize it again. So these are the optimizations that we have seen. On an average, we have seen 2 to 3x improvement. And this was a very small data set, like, 100 gigabytes or so. But if more and more you add more data set, you can easily see how much more performant it can be.
I think this is going to give a huge relief to customers that are pushing the edge of their system if they're running hundreds of concurrent queries,
Correct.
because only a 2x or a 3x speed up in caused by less CPU utilization. What that really also means is that people running their workloads with 70, 80% CPU utilization, trying to max out their hardware, they're going to see a massive reduction in CPU usage, and a system that all of a sudden becomes snappier and more free, and they can run more concurrency. And this is
Correct.
overall huge, huge improvement
Right.
in the performance of Greenplum.
Yep. Definitely.
Great. So I think we're about to move on beyond query performance, or maybe related topics, but between the improved query plans and the improved query execution, we're looking at a much faster database when you do the minor upgrade.
Another one is, hey, we have Analyze DB. Analyze DB is a very popular tool in 6 as well as in 7.0. It skips partitions. Like, basically, if you do an analyze operation and say 99% of your tables have not been touched, and you have one new tuple that is inserted into a new partition, and you run Analyze DB would skip the old partitions, right? And it will only support AOCO table. So what we wanted to do is, hey, can I support the whole variety of AOCO, heap, materialized view, all kind of partition tables, and have it inbuilt inside Analyze itself, That means if you run now analyze command, you'll get the same benefit on analyze DB. And on top of that, now even heap and materialized views on which statistics are done. So all of those things can also be can be run faster because you're skipping all of those the operations that you don't need to. Any partition that is not used, touched in a long time, and the stats are up to date, why bother doing analyze again?
I mean, it also makes the system more user-friendly because with Analyze DB, if you're very careful and you understand your workload, you can skip unrequired resource
Correct.
utilization. But if you're not quite paying attention and you're a little bit sloppy, just a little bit, you could be letting through duplicate workloads, and Analyze could be running duplicate times, taking up a lot of CPU. So now all of a sudden you're just getting like, wow, everything is just like it's less busy.
And Ivan, like all DBAs have principles, best practices, but when the customer actually writes it, the sometimes we are human, right? We don't follow the best practices. But what we are trying to do, Greenplum, is to have the best practices inbuilt so that you don't have to do that. It automatically detects, and even if you run 10 times analyze when there's no data that has changed, you still don't have to do any operation, any cost in the
It'll
background.
basically just return right away.
Correct.
Awesome. All right. Now let's talk about the desire for the perfect query plan and the desire for the perfect query optimizer and the practicality of hints.
Mhm. So, it's like 80/20. The famous rule, right? 80/20. 80%, it works perfectly. It's gorgeous. It's gorgeous optimizer, gorgeous execution. Everything is perfect.
How about 99 and 1?
99 and 1. Okay. 99 and 1. Then there's this one query that one BI tool wrote, right? And you want to like fix that. And you say, I know the statistics is, I just did the ETL load. I know this query is going to perform badly because I don't have time to analyze the data. I don't have time but I need to run this report right now after I finish the ETL load, right? How do I change it? If the one hammer that customers have always had till now is GUCs, but GUCs affect every query or in that session or in that database. Instead, what we want to do is to say, hey, for this sub expression, imagine you have like a 200-page query, and many BI tools have 200-page queries, right? They generate these, but I have this sub expression I want to use index, but I want to disable index because the statistics is not up to date, but the rest I want to have indexes. How do I do that? You don't have a tool. So with law, this Ivan, I cannot tell the number of times we've got requests for this tool. Now we have optimizer hints. Basically, you can have embedded hints inside the query, so when you have a workload that has this query and you know this pattern, you can now embed saying, hey, this sub expression, I don't want to have indexes. I want to have like a sequential scan. Or, hey, I would prefer you to do this kind of join or this kind of join order. Or this is the cardinality. Hey, I have not done statistics. Can you assume that the number of tuples in this table is blah?
Yeah, I mean this is awesome. And even for me on my home PC, playing around with queries just for fun, the ability to just pick exactly what plan I want, what part of the plan just allows me to understand the database and to play with the database and to even just to learn what's going on. All right. So hints are there. I'll focus on, I'll talk about this one because I spent a lot of cycles on this one. The Greenplum version 7.5 accumulates all of these capabilities, a long journey, which is sometimes called workload management, and being able to create simplified but powerful workload management policies in Greenplum, which support our biggest customers that have potentially up to 30, 40 million queries being run per day from thousands of different users. How do we manage it? The newest thing here is the concurrency soft limits. So the idea here was some customers are running large data extractions and they're filling up the concurrency limits, but the data is just downloading down to the client system. So we now support that as once the query is done executing and just downloading, that's one limit of how many queries are running, and how many are actively still running the workload is the other limit. So that's the hard limit and the soft limit. But along with that, in Greenplum 7.5 goes the disk space hard limit and soft limit, the disk IO, so how many bytes per second or how many IO operations per second, the CPU limits, both hard and soft limits, as well as the simplified memory management. So much less complex formulas than we've seen in the past as far as how to calculate how much memory we allocate per query. And last but not least, what's sometimes known as short query bias. You want your quick queries to finish fast, and your longer queries can be interrupted a little bit because you won't notice the difference. So we've got these query bypass scenarios for short queries. So all of this together represents really framework for workload management, which is all available from the graphical interface that you can manage and configure through the command center. Okay, let's move on to GP recover seg. This one really is a small, tiny feature, but gives useful, interesting feature to DBAs that are running recoveries and wanting to select specifically which content ID they want to run. We'll just kind of quickly pass through this, but it's important for DBAs to see this very nuanced tool that we give access to with the GP recovery seg -c command. And then, Venky, if you could talk about the new GP init system and what did we do and what's the benefit?
So what we have seen is with the Python-based implementation of how we manage the cluster, how we start, how we stop, how we init the cluster, all of these utilities, right, have been written in Python. We have to SSH. So we had a lot of performance as well as like, hey, we are not coming up with a new way of designing and defining all of these utilities, how we collect the logs, where we put it, all of those management. So what we have done is to move to a modern architecture. It's a rewrite completely in Go. And what we have seen is we have just compared the GP init system with the GP command line init system, and it's like 7 to 8x faster. And we have reduced the dependency on SSH, and like we are using the gRPC framework, so it's like a modern architecture, modern way of doing it. And each release going forward, each release of Greenplum 7, we will be coming to parity with all of the commands, all of the cluster commands that we have.
Yes. Nice. No, I mean, I can remember this is the third generation of utilities. There was a generation we built in Bash, there was a generation we built in Python, and now this modern architecture, which is more of a kind of a message passing, not a SSH kind of scripting approach. But this
Correct.
is really the next gen of how to manage Greenplum. And from the users, all you see is this GPCTL, which is the Greenplum control command. It's going to have different subcommands, starting with the init system command, but then eventually we'll have GP control stop, start, cover, all these different things built into a single management framework. So very cool. DR. Venky, you want to introduce DR?
So we have all of these wall logs. So what we want to do is we wanted to come up with a good way of doing disaster recovery, how we can, after we have the initial seed, how we have the initial all the changes that happen on the production cluster to go to the DR cluster. So we've been building on the disaster recovery solution for the past 12 months. And the basic architecture is you have the production culture, and then you have a backup and like a continuous wall archiving that goes to the archive location, and then we replay that into the DR cluster.
This is one of the hottest new features we have. I see many, like a high percentage of customers starting to pick this up because it allows the system owners for Greenplum to use Greenplum in a way that's more business critical
Correct.
than before with this software-based solution for data protection, disaster recovery. Greenplum now is elevated to the level where a higher tier of workloads can be trusted on Greenplum. And I think, yeah, the idea that sometimes there is a direct pipe between the machines and you're going to run direct replication, but sometimes you need to store that data in an intermediate zone because you've got a slow network in between and you want to make sure you have it archived safely. And lastly, here is the idea that some people don't even use this for DR. They're using it as an alternative to just data protection and backup because it's a very low impact archiving of every transaction with a very low recovery point objective, meaning that you lose almost no data in an outage. You don't have to wait since the last 24-hour backup. So people are using this just to archive everything to an archive location, and in the event of a disaster, just use it as a backup solution.
And recently, in this, we've also support now read operations can happen from the DR side, right? Basically, now this is a very powerful tool where you can have all of your read-only queries to be going to the DR replica rather than being bombarded. So now you have doubled your concurrency for read operations.
I've even seen people running GP backup on the read cluster. So they don't run the backup. Backup takes a little bit of load. So they run the DR to a read replica, and then they run the backup jobs off the replica, and they run those backup jobs, let's say once a day, but there's no load or locks taken on the primary.
Yep.
Nice. All right. This one is exciting, right? I remember again a long time ago when we introduced the first version of PostGIS in Greenplum and the excitement around the expansive types of data sets that Greenplum would be able to manage with geospatial modules. And in GP 7.5, we now have a total of 4 modern extensions that make geospatial data even more powerful. So ranging from H3 indexes, which divide the world into hexagons and allow you to search based on location and based on how many, what perimeter and diameter of the location you're searching for. PG point cloud, which is around LiDAR data and these like undersea drilling and other use cases that have LiDAR and being able to analyze that data. 3D CityDB, which is having elevation and street planning and information about parks and roads and waterways and very detailed information about cities. And then PG routing, which enables you to do routes within a graph and look for locations and routes of where you're going. So these are 4 highly in demand extensions on top of the geospatial framework. Speaking of extensions for analytics, Venky, you can introduce the improvement here for Apache MADlib.
So we are investing in Apache MADlib, and one of the dimensions we have invested is ease of use, right? Before you have to go through this Matpack way of installing, upgrading, or uninstalling. So instead, what we have is that going forward, it comes along with the RPM with Greenplum, and then all you have to do is to create an extension, right? As when you create an extension for MADlib and it gets installed, or if you want to upgrade it, you can just upgrade it easily. It's all a single command. It's just the ease of use of Apache MADlib. In addition to that, we are improving the MADlib libraries itself. We are
and let's be clear. I mean, this is a public video, so whether we may not be directly improving the Apache MADlib project in the future,
correct.
but
Our fork of the Apache MADlib.
Our fork of the Apache MADlib, and then you can go ahead and say what you're going to say.
So yeah, we are actively working on improving all of these algorithms, right? We are improving the Apache MADlib algorithms for classification, for regression, for tree search, all of these different algorithms and graph processing. Our goal is to make it 2 to 3x faster than what is there right now.
That's great. So in database analytics, at again, back to the keyword of speed. All right. And then this is a great graphic that you made, Venky, which shows a wide range of extensions available in Greenplum 7.5. And it really is robust. Like, so I think of it comparing it to MySQL. MySQL doesn't come with a lot of extensions, but when I look at this and I look at encryption, disk space data, key value stores, media files, network data, all the forms of geospatial, all the forms of machine learning and analytics, the fuzzy string match, just a lot of extensions that we provide to really make this rich environment of object relational data. Anything you want to add on that?
No, every release that we are coming out, we have 1 or 2 extensions we keep adding, because this is we are building an ecosystem where we have different kinds of workloads, spatial, security. We have different needs from different areas of our customer base. So we are enhancing it so that we can deliver them at the scale that Greenplum can deliver as an MPP.
I think it's worth noting that spatial extensions has a whole row onto its own that geospatial analytics and Greenplum really are two birds in a feather that go together, that we really believe in the geospatial aspect of Greenplum.
Ivan, just as like this is very close to my heart on the spatial one. Uh, we want it's very space doing MPP spatial is hard, right? Like if I have this world of spatial information, how do I distribute that data? How do I distribute it so that all your joins are co-located? We have a lot of interesting problems. I cannot say more on this. We have a lot of interesting problems in the spatial realm that we are solving because we have a lot of customers who have a lot of spatial queries that we need to run at scale, and that's what we are delivering.
It's very it's very outcome focused, right? It's very use case focused. People who have data, whether you're a shipping company or whatever it is you do, very outcome focused. And I think it's an area that we can really compete on a global scale with anybody when it comes to this this sector. And so we're going to keep pushing there. Okay. Now let's pivot from geospatial to AI and ML. Do you want to introduce this?
Sure. Whenever I did interviews with many customers, I've interviewed DBAs, I've interviewed application developers, or whether it is data scientists. Everyone has their niche, right? DBAs are great with SQL, but ML is very new to them. They're a little they look at all of these libraries and it's very complicated. And how do I set it up? What are the parameters? What is the right parameter? Am I doing it right? And then you have the whole class or species of people who are like the data scientists who love this world, this universe that they've created, which brings in so much value to the enterprises, but they don't like SQL. They love their R or Python or any of their utilities that they're used to, right? And then you have someone who dabbles in both worlds, right? So we have this disconnect that we are in database analytics. We provide this tool, powerful tool, which DBAs love, and they want to know how do I extract value out of it. And then I have all of these data scientists who are a little bit afraid of SQL. How do I bridge these two worlds, right? And that's what this GPML bot tries to achieve. What it does is next, if you can go to the next slide, what it does is like, hey, can I have a user driven way of teaching? Hey, I want to train something. That's my job. That's what I want to do. If a DBA comes in or a data scientist come in, can I run multiple algorithms to figure out which is the algorithm that is best for me to train? Can I rank those precisions and accuracies of those different algorithms and pick me the best algorithms? I don't know. Can you walk me through that? It's like a bot that takes you step by step. Or, hey, I have this hyper. What is the parameter that I can set for these algorithms? Can I run multiple algorithms side by side in parallel and find out which is the best and store those models? And then can I then use from the library of stored models and then predict something? Or can I, hey, I have this one cluster for Greenplum and I have another cluster for Postgres and another cluster for another Greenplum. Can I take this model and then export it to a different database, like another Postgres or Greenplum database, and run it there? Right? That's what we want to do. We want to train, we want to enable users to easily train, predict, and deploy their models. And that's what this GPML bot is, a CLI based solutions for now. And it walks the user step by step to get that achieved.
Right. And it kind of simplifies you as a buyer or a deployer of software, that you don't need to buy an auto machine learning tool or an ML tool set on top of a analytics runtime, or a framework that actually run the models. So this includes both the auto ML, which does the experimentation, and the runtime, which is Greenplum, in one simple interface that just
And
gives
generates the SQL for you. So you just store the SQL and you can use it anytime. You can change it. Say, for
an
example,
export
yeah,
and
and
export to another system.
export it. Yeah.
Yeah. So it's all in one. That's the idea is, and again, brings you back to speed, faster to train, faster to do experiments, faster to go to production, faster to then get it out and into a deployment. Okay. Number 15. So number 15 is a bit of a complex graph, but this is all about streaming data ingestion. We do streaming data in Greenplum now for some long time on Kafka and RabbitMQ. What this really talks about is the multi-node implementation of the Greenplum streaming server. So Greenplum itself is multi-node. That's how it scales. That's how it handles petabytes of data. Now, what this does is makes the Greenplum streaming server also a cluster on its own right, the GPSS cluster, so it can scale. So if you had to do billions or trillions of rows of data ingestion because you're doing something really, really serious and really, really important, you can scale the Greenplum streaming server as wide as needed to be able to handle that workload and do data transformations on the fly and get that data loaded in real time into Greenplum. And along with that, um, we have the Kubernetes operator, so you can manage that streaming server inside a framework like Kubernetes, because these are basically stateless services that are running, doing that streaming data processing ingestion. Okay. And then on number 16, which I think is the last feature we're going to talk about for this release, is really about the private cloud. So clearly there's other vendors who have specialized in solutions for the public cloud. And we started our private cloud journey in 2020 when Pivotal was purchased by VMware. And we're proud to be a very mature offering running in VMware Cloud Foundation, running in the VMware platform. I would say it's hard to argue that we're the big data system or the MPP database that has the most testing and the most certification and the most reference architectures running on VMware technology. And it is our home court advantage, and we are the big data solution for the private cloud. And as part of that, we have re-architected the data replication, and that we do offer both the traditional bare metal solution for your classic on-prem private data warehousing needs at maximum total cost of ownership, but as well for manageability. If you're looking for a cloud-like solution in the private cloud, the Greenplum on virtual now is extremely robust and running at petabyte scale at many customers. And essentially it eliminates the mirroring at the Greenplum layer and pushes down the high availability and mirroring into the virtual platform of the hypervisor and the virtual storage, and allows you to create a true private cloud experience for data warehousing or for data platforms. And yeah, it's awesome. So with that, Venky, can you introduce our new product, the Tanzu Data Lake?
So yeah, we now offer, we have many customers who have Hadoop, right? And they have all of their data on Hadoop, and they want to do MapReduce or Spark jobs on that along with our Greenplum offerings. So many of our customers that say, hey, we want to have one-stop shop of getting this whole Greenplum and this Hadoop ecosystem together. So in that spirit, what we have launched is the Tanzu Data Lake offering, and which comes up with our curated, our opinionated Hadoop distribution and a UI to manage the Hadoop distribution. Now with that and PXF, which is our platform exchange framework, you can now seamlessly query between your Greenplum instance. Your Greenplum is your querying instance, and all of your data lake or data storage of your unstructured data is all in Hadoop, and that is the Tanzu data lake, and you can query that and get the results as soon as possible.
That's right. And having been on this journey a long time and having worked at Pivotal, we had Pivotal Hadoop, a lot of lessons learned from Pivotal Hadoop and from Hawk. And there just keep coming back this idea that, are you a data warehouse? Are you a data lake? Are you a data platform? And I think the industry has kind of come around and said, well, maybe something like a lake house is really what we want, because there's the performance, the query performance of the data warehouse, the transactional capability with the flexibility and the elasticity of the data lake. We kind of need both, but we need them integrated and managed seamlessly together. And that's where we're coming here with Tanzu and the Tanzu data platform, which is basically Greenplum as the data warehouse, Tanzu data lake, and then creating this combined unified lakehouse solution, which brings the best of both worlds together. So it's really exciting, and we're seeing new deployments coming out on the data lake, and encourage people to check that out. Now, as part of a large public company, we don't want to be too speculative in our public announcements, but we do want to announce our under consideration for the upcoming releases, and this is really focused on the short-term roadmap and what's under consideration. And when it's under consideration, that means that we're pretty close to getting this released. We do also have 3-year, 5-year, and 10-year roadmaps, which paint the vision in our minds for where we want to take this platform in the future. Where's big data going over a 10-year period? What's the future for the whole world? But we don't want to get into that because it's too speculative here. So let's focus just, Venky, on the under consideration for the short term, what we want to deliver. So let's start with the first one.
Want
You
to
want to
take
go
that?
first?
You
I'll
want to
take
take that? Okay.
this one really came from a lot of the private cloud, so-called dark sites. We've got very sensitive systems where people can't access it from home. They need to actually drive to the office if they want to touch the system with their own hands. They don't enable remote access. And so self-healing and auto recovery of failed segments, this is something that we have built into the future versions, and looking forward to, having this auto healing, auto recovery of failed segments kick in and help people to just have the system running with less human involvement as we go. So it's really important. I don't want to overstate it, but it's important. Plan generation improvements, what we have
So,
planned.
so we have, just going back to the previous one, parity and speed. That's what we are focusing on. Orca will generate better joins for null handling. So, say for example, if you have an inner join where there's many nulls, how do I prune those nulls early? We will be supporting lateral joins very soon. Also, if you are expanding your database, adding new clusters, and you have some tables that are partially distributed, how can we handle better? Supporting heterogeneous multi-level architectures. This is really cool for 7 that is coming out soon. Improved columnar data execution. How do I pick better indexes? How do I handle columnar queries to generate faster execution with faster plans?
Yeah. It's awesome. It's amazing to see every release, to see workloads just getting better and faster. So this is awesome. From the encryption point of view, for a long time we have supported disk level hardware encryption for Greenplum. We have PG crypto, which is application level encryption. But now the feature we're working on is transparent data encryption, which basically has Greenplum encrypt every single bit of data. So if someone SSHs into the box and tries and does a Linux command, all they're going to see is encrypted files. So this is important. This is important for security. It's important for regulators. It's important for customers that are in regulated industries. So looking forward to this one. Improve PXF, Venky. Can you pick
Yeah,
up this one?
so we are seeing PXF being epicenter of moving data out of our other data warehouses, data lakes. We have seen PXF to be at the epicenter for federated query processing, federated data loading, many different use cases. One of the things is, because it's getting like a billion rows out of some other system is very expensive. One of the things that we have seen is you can have a compute node where the PXF can be external to Greenplum. So you can still have the concurrency not be affected on your main Greenplum cluster while PXF is compressing or like uncompressing the files or Parquet files from any other external sources and then fitting it to the Greenplum format, getting data in or getting data out. So having an external PXF really gives you the extra horsepower to do massive federated query processing and query data processing. The second one is statistics as external table. Now that we have the data lake, we have the Greenplum data warehouse, we also need statistics on those external data systems so that we can make better plan choices, so that we don't leave any optimization techniques on the table. So that's one of the things that we're focusing on.
And like Orca, PXF is a bet we made over a decade ago in the future of the data platform, which sometimes it takes 10 years to see the benefit come through in the
Right.
way that it needs to come through.
It's harvest season, Ivan.
Yeah, in an enterprise product like this. So this PXF technology, this PXF platform is a framework which is really enabling these data platform, the data lakehouse, the the federation and all of these new use cases that have data warehouse at the heart, but then create bigger and broader data platforms that we're seeing the future go to. Okay, and then announcing the Greenplum SQL editor, Venky.
So we wanted to have a native SQL editor that we can provide to customers so that they can write their SQL, make sure that it matches the Greenplum SQL format, make sure that it has Kerberos support. You can have view the plan, see the progress of the plan, fix auto complete your SQL queries. So there are different. We have had many customers saying, "Hey, can you provide a Greenplum build solution for this?" And that's what the Greenplum team was building on.
And this is in addition to the Greenplum Command Center, which is for DBAs, right?
Correct. This is for any native user of Greenplum, not
Right.
the administrative user.
Okay, so it'll be yet another graphical user interface that we have in addition
Correct.
to. Okay, great. All right, and in-place upgrade for Greenplum.
So the first part actually, one of the things that we for 5 to 6 we are doing we have one or two customers who are still on 5 who are migrating. So how can I have quick statistics copying statistics from GP5 to GP6 so that they don't have to do the analyze and waste time because they want to get their system up and running and live, and then prioritizing newer partitions to be indexed before the older partitions. That is from 5 to 6. From 6 to 7, we currently have a backup restore option, but we are actively working on an in-place upgrade. So we will be for each I think next release we will have next to next release we have multiple milestones where we say, hey, these kind of in-place upgrades will be happening. So in the next couple of 3, 4 releases, we will have the complete spectrum of in-place upgrade.
Nice. Okay, good. So that way they can unlock the power of GP7 for people
Correct.
with heavy workloads on GP6. And then I'll take this one, the Kubernetes. So this is the second time we've come to market with the Kubernetes offering. I think the first time we came to market with a Greenplum Kubernetes, we were like the early adopter, right? When Kubernetes came out, we didn't get too much pickup, and frankly, we didn't have enough experience with Kubernetes. Now the Tanzu team collectively has a lot of experience with Kubernetes. We've built our own Tanzu Kubernetes products and distributions, and we have a massive amount of experience with Kubernetes. We've also shifted Greenplum for the private cloud to have the mirrorless solution. And the mirrorless solution really separates compute and storage, which makes the Kubernetes version of Greenplum a lot more of a manageable problem than running Greenplum with mirrors. And so we're coming to market again with a Kubernetes operator, and we see certain customers who have standardized on Kubernetes as their infrastructure excited to see a Kubernetes version. And one of the most exciting use cases I've heard is a Kubernetes customer wanting Greenplum in order pretty much purely to use it as a query federation tool, where they're going to access 100 remote sites through PXF and use that as a way to aggregate data together from disparate databases around the world using Greenplum and using Greenplum with Kubernetes. So we're excited to bring this one forward, the Kubernetes version of Greenplum, and hope that if you're a Kubernetes investor, in the sense that you're investing in Kubernetes platforms, that Greenplum is a friendly tool you can run in that environment. And then, Venky, you want to talk about your
Yeah,
plans?
so we already touched briefly on the improvements and the algorithms of Apache MADlib, the fork on the VMware.com fork of Apache MADlib. We are also going to be supporting hyperparameter search in that offering. In On the dimension of GPML part, what we are working on is, hey, now I have train, we have predict, we have deploy. We also do data preparation because 80%. I've heard some data scientists spending 70-80% of their time doing the data cleaning, how to handle nulls, converting to categorical encoding, different kinds of cleaning. So we want to have even the cleaning operations of the data be like user driven rather than writing SQL just a CLI driven. And then also support model versioning and exporting this model to say, for example, we have many customers who have Gemfire as well as Greenplum. They said, hey, I have these kind of transactions, I have modeled it, now I want to run it on our in-memory cache in Gemfire and predict fraud, for example. So how do I export those kind of models to Gemfire? That's another one we're working on.
Correct. And this is the idea that the models become living software that run in real-time systems, that they're not just models to create a PowerPoint showing what you can predict. They're models that you can deploy to production in a real-time environment, and it becomes a fully software-defined platform for ML and using ML and getting feedback and making a smarter enterprise that you're running. And then Vicky, your new diagram. Maybe
Yeah,
just a
so
quick walkthrough of the scope of the Greenplum platform.
yeah, this diagram has basically, we have to thank all of our customers for all of the places and how all of the ways that they use the software that we build. So we have many customers having data in different kinds of locations, file systems, relational database, object stores, messaging system, other data lakes or lake houses. And then we have to ingest them, and we have three defined data ingestion strategies, whether it's GP load, streaming server, or PXF. PXF is a federated query processing tool. And then we also have plugins to different softwares that people use, like Apache Spark, NiFi, dbt, Informatica, or Tanzu Gemfire. So these plugins, along with the data ingestion tools, you can feed in the data into our warehouse, which gives you a very state-of-the-art workload management, query optimizer, different indexing strategies so that your transactional queries work, SQL compliant, it's massively parallel, have polymorphic storage with different AO, CO, heap, different kinds of partitioning. And then you have it's built on the foundation of Postgres kernel, and it also has foreign tables so that you can have, foreign data wrappers of Postgres, based way of pushing predicates and pushing aggregates. That's the core offering of Greenplum, and it supports a whole ecosystem of AI, ML tools, spatial tools, and text analytic tools. We have a user interface which is for the administrator, which is the command center, and a SQL editor for the regular user. We have disaster recovery strategies like GPTR, which can then be used as a read replica. And then you have backup and copy strategies, which are traditional archiving strategies. From an operational perspective, we have in place upgrade for 5 to 6. We're working on 6 to 7. We have cluster management tools, which are now being rewritten in 7, but we have the older Python base still exists and very much in use by our customers. We have different ways of cloud tooling so that you can manage you can deploy it on Azure and different public clouds. We have our GP virtual offerings, mirrorless offerings, and as Ivan said, our home code advantage with our VMware offerings, and then the Kate operators, so that with the new modern ways of deploying software, we also have the Kubernetes operators. So this builds the whole ecosystem where people can store data in different locations, ingest it, get value out of it, you analyze it, and also do operations on our data warehouse.
That's right. And I mean, and what comes to my mind, just finishing up this quite long 1 hour plus talk, is Broadcom's focus on R&D and Broadcom's focus on advanced technology. If you look across the Broadcom portfolio, whether it be their custom AI chips, their custom network components and interconnects, the advances in hypervisors and virtualization, I think having that kind of attention and focus put into the Greenplum data platform, that with the Broadcom muscle, there's really the sky's the limit as far as where we can go with Greenplum and with data processing under the sponsorship of Broadcom. And we're just really happy to announce Greenplum 7.5 and
Correct.
all those benefits that the customers will pick up and any new customers are going to pick up. And yeah, please use the product and enjoy it. It's a great solution. So thank you. Any last words?
It's a lovely journey, and we're going to be delivering a lot more cool features in 7.6, 7.7, 7.8. this is our heart is in development and offering quality solutions for needs that our customers are facing day to day.
Yeah. All right. Thanks, everybody. Take care.
Bye
Bye-bye.
bye.